Today we are exploring hanging and sleeping in blast furnace, a key operational challenge for stable iron making. Understanding its causes of such hang and sleep uh, is extremely important, and we need to come up with the final outcome of the reasons and corrective measure. Otherwise, furnace will be messed up and a chronic problem of asymmetric, lesser productivity, uh, poor wind acceptance, hang and sleep, etc. will occur. So furnace is surrounded by a lot of additional issues, and production becomes deep down. So the fundamental cause of poor body descent, including hanging and sleeping, is the formation of non-collapsing bridges of melting or burden in cohesive zone. This glue burden material create voids below them, eventually collapsing suddenly in a slip. This disrupt internal layer structure absolutely and mess up, and from again a operator, the shift person has to configure the each layer uh, right from scratch. So this disrupt internal layer and impeding gas flow and potentially causing a even extreme situation of chilling short of trend also. Now coming to our slide about a uh, causes, and here we can see what are the basically causes of such type of anomalous situation. So one thing which is very common is excessive upward gas pressure, and excessive upward gas force from the gas pressure is measured in terms of delta P process. So this excessive force from gas pressure is a major factor, and if the pressure difference delta P process between blast and top pressure exceeds its maximum allowable value, typically 1.6 to 2 bar, operation becomes erratic, leading to frequent hanging and sleeping as the force counteract burden descent. Now, one of also a important reason is high liquid level in the hearth. So high liquid level of the molten hot metal and slag in the hearth significantly impede burden descent. The buoyant force on submerged coke presses upward as it is shown in the slide, and the buoyant force on submerged coke presses upward through the coke grid onto the cohesive zone, reducing wardage and permeability in the softening material. This also creates asymmetry affecting two air opposite the taphole. So it is really a very important phenomena that occurring when we don't have a right evacuation. Similarly, a poor body permeability, often due to excessive fines content material less than 5 mm, as we have discussed in our earlier presentation, also reduces void fraction and increase gas flow resistance. These fines from charged material or reduction disintegration, as we come across earlier presentation, where one is the fines that is being carried by the from the raw material source, and another is the low temperature breakdown. Such type of fines are getting generated in a temperature band of 500 degrees centigrade inside the furnace. So these two phenomena of generation or ingress of fines from these two phenomena are to be looked into. So these fines from charged material or reduction disintegration are as we have discussed, they form a concentrated ring inside the furnace, impeding gas flow and perpetuating the permeability issue on a drastic scale. And it is difficult to run the furnace in such a situation. Now, coming to the thermal deterioration of the furnaces, particularly in context of such type of hang and sleep situation, is also quite obvious, because in this situation a lot of material are not processed as per their temperature range or temperature band correctly, and this causes a more thermal load on the down below direct reduction processes of the furnace, which consume a lot of heat input, creating a thermal condition in a downside, and this leads to a cooler output, may also burning of tuyeres as cohesive becomes very nearer to air, and many times the backflow of the cold metal and slag in blowpipe also has been observed in different furnaces. So we can say that suboptimal softening and melting properties of burden material are also critical, and material that soften or melt at low temperature or have a wide softening melting range can create an impermeable layer high in the stack, hindering the gas flow and promoting the breach formation. And many times we come across also a phenomena where inadequate or poorly distributed coke layer causes ferrous layer to contact, forming thick cohesive zone that are impermeable to gas. These zones directly lead to breeze formation and unstable body descent. And as we just recently also discussed about a chilling trend causes the thermal instability in direct reduction, increase in direct reduction consume coke, accelerating the Boden descent and driving the cohesive zone downward. If uncontrolled, this zone can reach to air level and solidify, and causing a severe chill and persistent breathing. And the insufficient gas reduction is also one of the phenomena which shows its symptom in the upper furnaces, often due to high moisture or fines, forces more direct reduction in the lower zone. This accelerate descent and consume coke more quickly, contributing to operational instability. Coming to the adherence to the furnace wall, we can say that adherence to furnace wall, like a scaffold accumulation from the high alkali zinc or fines, can severely disrupt body descent. Scabs are unmolten material resting on the tuer or causing blockages, directly contributing to the breeze formation. So as we can see that this is also a very important phenomena. Water leak and moisture issues are also very sensitive, and as we know, excessive moisture input from the charged material or injectants prolong drying, potentially creating a condensation evaporation cycle. This drives the active reduction zone downward, reduces efficiency, and causes irregular body descent, and even leads to tuer failure, which gets converted into outrages of the furnaces. So, in conclusion, hanging and sleeping are very complex issue rooted in non-collapsing breeze in the cohesive zone. Key causes include excessive gas pressure, high liquid level, poor permeability from the fines, suboptimal material properties, inadequate coke, thermal instability, insufficient gas reduction, wall adherence, and moisture issues. A holistic approach is very vital for the stability of all the furnace operation. And as we can see, there's things these are the information related to inadequate cochlear, which we have already discussed. The thermal condition instability is also being shared in this slide.